And then on top of that, we have got sensory networks, which include, for example, visual network, auditory network, gustatory network, olfactory network. Then we have got attentional network. This is very important. Along with the higher order network, attentional network are very, very important. Okay. So if you think of, there are two types of attention. One is, so let's do an experiment. You come here. Okay. Suddenly. See. Now you look, sit here. So follow my finger, okay, with your eyes. Don't move your head. So what happened? So he's following. So that's a top-down network. I've asked him to follow it, and he's doing it intentionally. Now suddenly he make a noise. What did he do? He suddenly see on that side. So that's the ventral attention network. So there are two types of networks. One is top-down, when for a command you are following it. So you are doing it from top. So you are following that command. But suddenly something happened. If there is a, like, it shouldn't happen. If there's a blast, what will happen? We will suddenly, whatever you ask to follow, we will run away. That's because that attention is always will take over. So there are two types of attention. Okay, thank you. So these attentional network are ventral attention network and dorsal attention network. And finally, there are other networks like language network, limbic network like emotion. So these are the other network. For this talk, we will forget all the sensory and other network. We will concentrate on the higher order network and attentional network. Next slide, please. So yeah, let's go like this is the next. Let's go to the next one. So one of the important network is the higher order. As I've said, is the default mode network. Okay. Even when you are listening to me, suddenly your mind might drift to something completely different. What are you going to do this evening? Okay. What meal are you going to have? Like something completely different. So this is what is called the self-awareness. So where you are internally drifting to something, internally drifting to your senses. And that's the default mode network. So we have got this internal thinking going on all the time. Even if you are doing something actively, suddenly you might drift off. Okay, so that's the default mode network. The part of the brain which is active when this network is working is the medial prefrontal cortex. So that's why I've drawn this. So I'll do this spin. So medial prefrontal cortex. So that's the part, default mode network. Second is the posterior cingulate cortex. So it would be around here. Okay. And there is angular gyrus and precuneus. So angular gyrus would be around here and precuneus would be around here. So these are the parts in the above the tentorium. These are the parts which are active during this. And then the cerebellum is affected, like cerebellar tonsil and cerebellar vernal. So whenever we are doing this internal thinking, okay, this part of the brain is active. Okay, and that in normal situation we do it all the time. So that's default mode. Next, please. Next is this salient network. Go to the next slide, please. So next, I will come back to salient. Next is the central executive network. So next, when you are actively concentrating and trying to solve a problem. So for example, you are actively listening to me now and trying to understand what is reality. So that's where this network will be more active rather than default mode network. So what are the parts of the brain? So this here, the dorsolateral prefrontal cortex. So let's give a different color. So dorsolateral prefrontal cortex and the posterior parietal lobe. And in case of, again, cerebellum is also involved. So what is doing? Goal-directed behavior. So for example, you are now more on central executive, but not completely. Working memory or cognitive flexibility. These are their function. Okay. Go back. So next is the salient network. Salient is like this switch. So in normal state, we are fluctuating from default to central executive all the time. Okay, sometimes we are more in central executive, sometimes we are more in default, but we fluctuate. And who is the switch? That's the salient mode network. So that is switching us from one to other. That's why sometimes you are internally thinking, sometimes you are trying to solve a problem. Even when you are trying to solve it, sometimes you drift, because in normal state the salient mode network is the switch which is drifting. And so that is, and which we have already discussed the parts. Okay, so these are the three most important higher brain network, higher order brain network. And on top of that, there are two networks which are the attentional network we have said. One is the dorsal attentional network, where you are top down. So you are following a command, you are putting the attention, as I said to him to follow the finger, he's intentionally doing it. But as soon as there is a bomb blast, for example, he won't follow it. The attention would immediately, automatically go there. That's the ventral attention. So for the dorsal, frontal eye field, so it's around, let's give a different color. Frontal eye field, then the interparietal sulcus, so that's the particular area, and also cerebellum, cerebellar vermis, and the vestigial nucleus, because the eye movement is there like this. These are the part when there is voluntary. So it's a top-down, goal-directed attention, and it is important to know it involves both hemisphere, right and left has to be involved here. Okay. Next slide. For ventral attention, on the other hand, when there is something, where, sudden sound or sudden something, if there is somebody throw something to you, even if you are following something, that will take precedence. So that's the ventral attention. Which part? So these are the, for example, ventral part of the frontal lobe and temporoparietal junction, so around this area. So these are the two areas which are important in the supracortical area, and then midbrain, superior colliculus and pulvinar, which are involved here. So, okay, so is in the thalamus. So these detect unexpected salient stimuli, reorienting attention lateralized to the right hemisphere. Okay, so these are the most important network what we should be aware of to understand this. Okay, next slide. So now I'll go through some of this theoretical model, how the brain works. Okay, so that is the theoretical model. It's based on the free energy principle and predictive processing. Now imagine yourself being your brain. Okay, imagine yourself, you are the brain. Where are you? So you are sitting inside this skull, which is completely dark. You are drowning in CSF or in fluid. Okay, what have you got as a tool? Is some electrical impulse coming from different part of the body, and you have to make a sense of this electrical impulse to create a reality. So have you ever thought like that? Your brain is sitting in a dark enclosed space covered by fluid, okay, and it is just connected to outside with the is getting information as electrical impulse, and it has to make sense of it. Okay. So that's the challenge brain has got, and how the brain is taking that challenge. So brain is working. So if the brain has to take all this information and process and create a reality, it would never work. Okay, because there's so many information, it is not possible for brain to crystallize thing and give a reality what we are doing now. So how does the brain work? It works as a predictive machine. Okay, instead of relying on all the information what is having, it is predicting in the first instance what is happening. Okay, then all this information, the sensory information what is receiving, it is trying to corroborate whether the information what we are receiving is synchronous with my prediction. Okay, just imagine like brain as a scientist always predicting about the weather. Okay, so they are predicting that this is the weather going to be, and next we have got radar data and everything which is showing what the weather actually is, and then there is corroborating. So what the free energy principle dictates that brain is always trying to predict in such a way that there is minimum error between these two, between your prediction and the raw sensory data. The discrepancy is minimum. So that's what the main role of brain is. So one is the prediction part, and second is the information they are receiving from the, for example, from the radar, and then the two should coincide. Okay, that's what the function of the brain. But on the other hand, just imagine if the brain has to receive all the information and then create a weather forecast, then it would be very, very difficult. Okay, so that's why it is creating a reality first, or predicting that this is happening. So if I am looking at this screen, I am already predicting what is there. Okay, and if, for example, if suddenly a monkey come out of it, that is not I was expecting. So then that's an error. So brain will immediately correct. Next time, probably if I see that screen, I'll expect that the monkey will come. And if it doesn't come, if it is same, then it will be an error. It will try to correct. So that's how the brain works. So it is always projecting the reality. So I see Phil, he's like this, and suddenly, if he suddenly become very smart and very good looking, I'll be surprised, and then I'll change my reality. Okay. So that's how the brain works. Is that clear? Okay. That's next slide. So, Phil, I didn't mean to say that. It just came up. So what is? Brain has got an internal model or a schema, be it sensory, whenever it's doing a motor task, it has got a program already. Okay, so that schema, based on this schema or internal model, it is generating that if I touch it, I'll feel like that. I'm not expecting it to be hot. Okay, but if it is hot, suddenly what will happen? I will realize that this is incorrect. Brain has predicted, so I have incorrectly predicted that. So I'll then correct. I'll move my hand, and then next time when I touch, I'll be very careful. Okay. So it's internal model, which is schema or the enneagram. So that generate prediction using the internal model. Now, if there is prediction error based on the available sensory input, then it will understand that there is area, and that is very important for learning and correction, and next the model will update. Okay, that's how the brain is doing all the time. Is that clear? This is a basic concept. Now it is not so straightforward. There is a concept called precision weighting. Okay, so there are two aspects. One is my internal model, another is the sensory information what I am receiving. Now brain don't give equal importance to both. Okay, sometimes it can give importance to my internal model more. So even if the sensory information is saying it hot, if my internal model say that it is not hot, then brain won't get that much of a surprise. Okay, or it might give more importance to the sensory data and reduce the importance to the prediction it is doing. Okay, so the precision weighting is the brain, they don't treat them as equal. Okay, they don't treat these two information as equal. Sometimes it will give to the prediction model more importance, and that will create the reality as like that. Sometimes it will give more importance to the sensory data, ignoring the prediction model, and that will be the reality. So for example, if there is a pain, if I get the same stimulus of pain and you get, we don't react in the same way. Why? because my internal model is saying, oh, this pain is nothing, okay, then I will override the sensory information. On the other hand, if somebody saying that they are giving more importance to the sensory data and giving not much importance, so their prediction model is saying that it is not very painful, but they are giving more importance to the sensory data. No, it is more painful. So brain might sometimes do that way. The sensory, they give more importance and you feel more pain than what is expected. So that's how, what is the precision weighting means. Okay, so one is the prediction model plus sensory data they are comparing, but when they are comparing, they are not giving equal weight to both. Okay, so depending on how much weight they are giving, the reality will depend on that. Is that clear? Okay, next slide. The other is, the concept is sense of agency. Now I pick up this pen. I picked it up. Brain is creating that reality. Okay, so that is also a function of the brain. It's creating that I am doing this. Okay, so for example, you try to pick this up. What did I do? Pushed it up. So what happened? Why didn't you pick it up? So because he's putting the blame to me, that you pushed me, that's why I couldn't reach. So when you are planning, when you are predicting something, okay, and then you are executing it, if these two coincide together, that's what creates the agency. That it is me who is doing this. I have taken a decision and that is successful, or it's me, I have done it and that's, but if he's trying to do something and somehow, whatever happens, it didn't, so he's putting that it's not me who haven't done it, it's because I have pushed him, that's why he couldn't do it. So this agency is also an illusion of the brain in a way. Okay, it's creating that reality that I am picking it up. Is that clear? So it's a bit abstract concept, but that's the agency. Agency means whatever I am doing, I am feeling I am doing it. That's the creation of the brain, and that's when you do it, when you predict something and you have successfully done, the agency gets more stronger. On the other hand, or if you have to take a lot of effort to convert your prediction and you are successful, then you feel even more stronger that it is me who has done it. Okay, so for example, if you win a trophy, you feel even more, oh, it's me who have done it. That's because the agency is stronger. On the other hand, if you don't win it, oh, it's because this happened, that's why I didn't do it. So that's the concept of agency. Okay, next. So how does the brain? First is predictive brain predicts sensory consequence. Okay, what's going to happen? Then it brain compare prediction and reality via sensory feedback. If it matches, there is the sense of agency. So what are the parts of the brain which are involved? One is the prefrontal cortex, which is planning and decision making, parietal cortex and cerebellum. So these are the three parts of the brain which are working together to give you a sense of agency, that I am doing this, I am moving my limbs, I am talking, okay, I am seeing things. So that's what is the agency. Next slide. So how does brain create normal reality? So it's a complex interaction between various cortical and subcortical structure. It creates reality by prediction, so it is predicting something, okay, and then it is seeing whether from the sensory information they are receiving and giving the precision weighting, they are giving the attention to the area what they think is more important, and that's how they create reality. So in other words, what I see this world is not exactly same as what you see. They're slightly different because your prediction or your previous experience is different, so you are predicting differently, and what sensory data you are receiving and then giving precision weighting to these two is slightly different, so the reality is not the reality. So what you think is real is not actually real. Okay, so that is the illusion, in a way, controlled illusion created by brain, and it is important to understand everybody's reality is slightly different. Okay. Next. So these are the cortical and subcortical structure. For prediction, various neocortex like visual cortex, auditory cortex, somatosensory cortex, prefrontal cortex, hippocampus, amygdala is important. For precision weighting, which should I give more importance? Is it the prediction or is it the sensory? That's where the prefrontal cortex again and thalamus is very, very important. Now, depending on the precision weighting, you will put attention. That's where parietal cortex, prefrontal cortex, thalamus and reticular activating system is very important. And the error correction that you have predicted and now the reality is not, the sensory information is saying that is not what is I have predicted. Then you have to correct the error. That's where again the prefrontal cortex, anterior cingulate cortex, insular cortex, basal ganglion and cerebellum come into action. And interplay of all this area of the brain is creating this reality what you feel. Okay. Next slide, please. So in terms of network, for prediction, 3 networks are important, which we have said the higher order. Default mode, the executive central network and salient network. These 3 networks, what we have discussed, central executive network, salient network, default mode network. So again, in normal situation, you are flipping between these, either default or central salient network is doing. So that's creating the prediction. And then precision weighting, so which is more important, is the prediction or the sensory information? That's the attentional network is driven to that is creating that. And then the error correction is done by the salient network and the error monitoring network, like parts of the insular cortex and all the other parts. And effect of that is the reality, what we are seeing. So what we are experiencing now is that effect of the brain causing this reality. Okay, next slide. So what is hypnosis now? So we have got an idea now. So brain is always predicting, and then once the prediction is done, then it is also receiving the sensory information. Now here it is weighing which one I should give more importance, equal or one more, one less. And then whatever we do based on the precision weighting, then the reality is coming into place. Okay. So if I feel that this is not hot, although it's hot, I won't feel hot. Okay. So what happens in hypnosis? It's a temporary alteration in predictive processing. Our predictive processing is changing temporarily, be it. And brain become more reliant. So rather than having a previous idea what this would be, the suggestion is given more importance. Okay. And that is given more weightage. And that's why it creates a suggestion is accepted and creates a new reality. So that's what the reality is. So that's why in hypnosis, if if you say that you see that you can see your food and you can taste the food, they can do that. Okay, and that can sometimes be much more than actually when you are. The reality in hypnosis is much more exaggerated than in normal situation. Okay. Next slide, please. Okay. So how hypnosis is happening? So remember this default mode network, that is the internal thinking. As you are hypnotized, this default mode network gets inhibited. So your internal thinking gets inhibited, it gets stopped. So you are not internally thinking. What you are doing more is this salient network is connecting with the central executive network. So it's a new prediction. As we have said, the prediction is done by combination of these 3. Now the default mode is taken off. Okay, and the new prediction is done by these 2 network interaction. So these 2 salient and the central executive is creating the prediction, and that is given more weightage. Okay, and that's what is causing the reality. Even if the sensory data is saying that there is no food in front of me, because I am giving more importance to the prediction, what I have done, you are able to feel that you are eating. you are able to sense the taste coming out from the food because you are giving more weightage. That's because suggestion has been given. That's the new reality. Okay, next slide. So this is again a slide showing what happens during hypnosis. Subject relax and focus. Reduced activity in the dorsal anterior cell. So it's a part of the cingulate cortex. It is divided in two parts. One part get inhibited, and there is decreased connection between the default mode network and central executive network and the salient network, and prefrontal cortex get more active. That is central executive and the salient network, they are more active, and that's what gives the reality. Okay, next. So what happens in functional neurological disorder? Okay, functional neurological disorder, somehow because of either your previous experience in life or you are genetically more prone, whatever might be the case, you have disruption of the predictive processing. Prediction is not what should be in a typical person. So their prediction. In hypnosis, prediction is different, but that is temporary and that is brought on by suggestion. Prediction is different than the typical individual, but that is their life experience, their gene probably as well. So they develop abnormal prior leading to wrong prediction. So they are giving, so if I have to move the limb, I can predict, oh, my limb will move like this. But their prediction is wrong. I cannot move the limb. Okay, even if the sensory information is, and they cannot correct the error, even if the sensory information is saying, oh, you can move it, it can be moved, it is not giving importance to that. It is giving to a wrong, maladaptive prediction. And that's why this cascade continues, resulting in neurological symptoms. So that's the idea. Next slide, please. So what happens in hypnosis? Exactly the opposite. Just move out, like just to, it will confuse. Just move to the previous slide. So what happens in hypnosis? What happens in functional neurological disorder? Unlike hypnosis, in hypnosis, salient network and central executive network, they are more active, and that's why they are creating a new prediction. Here, the default mode network and part of the salient mode network is more connected, and the central executive network is switched off. In hypnosis, this is switched off, this is more connected. Here, in FND, this is switched off and these two are connected. So it's exactly the opposite. Okay, and moreover, they have got more limbic system, but this is the fundamental. So their prediction is different, is atypical, and they cannot correct it anymore. And that's another because of the network. I'm not going into that. Next. Move to the next one. Okay. So why hypnosis what? Now there is no evidence why, but this is my hypothesis, and my next endeavor would be to prove that hypothesis. So what if you imagine that this is the salient mode network, and you come here and you see it come here. Okay, this is my salient mode network. Okay, so sometime, so he is default mode network and he is central executive network. In normal situation, I will do this, that is the reality where it is fluctuating. Okay. In case of hypnosis, I am the central executive. I'm just forgetting him. I'm just talking to him only. So my vector shifts to the right. I become more like a rightist. Okay. Whereas in functional neurological disorder, I become this. Okay, so the vector is more toward the left. So my theory is, because normal state is we are doing this, in hypnosis we get this, in FND we get this. Now when you come out of the hypnosis, you then start to become like normal. So that's what you are, back to the normal reality. You become like a typical one. Okay. All these part are already proven, but hypnosis, it is bringing back. Nobody has shown that. That's my, whether if I can prove that, then it will complete the hypothesis. So that's what is hypnosis, and that's it. Okay, thank you very much. Any questions?